The food that we eat every day has a huge effect on the bacteria that live in our gut. And this in turn has a huge effect on how we feel, both mentally and physically. And this is even more true for those who are just starting out in life.
The first 2 years of life are a very critical period for interventions to promote the best outcome in terms of development later in life. It's also during that period that the microbiota is established, and it's in a state of flux over the first couple of years of life until it settles down beyond 2 years of age.
In order to learn more about the types of bacteria that live and grow in a baby's gut, Catherine and her team at Teagasc Moore Park have been following the development of 150 babies since they were born as part of a project called INFANTMET.
We established the INFANTMET programme a few years ago, where we recognised the importance of early gut microbiota in health and wanted to establish the baseline microbiota associated with breastfeeding, which is the gold standard infant nutritional regime.
Breast milk is an extremely complex substance, so is it possible to recreate it or synthesize it in a lab?
Well, indeed, you're right. Breast milk is extremely complex, and in particular, it has a large array of complex polysaccharides that actually aren't digestible by the infant gut, but are digestible by the microbes.
So you're saying that in breast milk, there's not just food for the baby, but also for the bacteria as well?
Absolutely, yes. And because the baby cannot digest these complex polysaccharides, but the microbes have the enzymatic machinery to do so.
The way babies are born can affect the growth of their microbiota. So researchers were keen to find babies that were delivered naturally, by cesarean section, and prematurely. And where better to find them than at Cork University Maternity Hospital, where babies come in all shapes and sizes.
INFANTMET is important for us in the unit by just collecting stool samples, measuring the babies, doing neurodevelopmental checks on them at 2 years. They're providing us a lot of information. Irish mothers are providing us a lot of information. And we have found that the Irish families are very, very altruistic and will participate in these studies.
One of the many children who took part in INFANTMET is Oisín Lynch from County Cork.
And I had a cesarean section to bring Oisín into the world because he was very comfortable. He was born at 42 weeks and it was time to let go. I was really happy to meet him. Caroline asked if we would like to contribute to the study. We had a schedule, so when Oisín was 2 weeks and 4 weeks and 6 weeks, we took samples from Oisín. So the samples consisted of Oisín's poos, so we didn't need them, so we may as well donate them on to a much better cause. It's actually really nice to see that contributing to a research project was actually part of our lives, and it's nice to see that research can be integrated into very, very normal activities, and it was absolutely no trouble and was a pleasure to be involved.
Ciara Murphy and Claire Watkins have been analysing the samples provided by Oisín and the other babies in INFANTMET.
What we do is we extract the bacterial DNA and then we use DNA sequencing to identify what bacteria are living in the sample.
Why is it useful for us to know about the types of bacteria that are in the guts of babies anyway? What can we do with that?
It's been shown that infants born by C-section and preterm infants, that they tend to have higher rates of things like asthma, allergic diseases, and they're more likely to become obese later on in life. So our theory is that these differences in the microbiota composition could be linked to these health effects that we're seeing in these infants as they're older. So we're hoping that the information that we've learned here in INFANTMET, the differences in their microbiota composition, that we can use this in the future possibly to develop probiotics that we can give these infants who were born by C-section, who are preterm, and try to repopulate their microbiota into a manner that's more similar to a full-term naturally delivered infant.
The samples provided by babies like Oisín are helping to build a picture of what's been happening in their guts since the time they were born.
We take our fecal samples into a pathogen lab where we isolate them for specific types of bacteria, and we have to recreate an environment very similar to the gut. So we might take 3 or 4 days for them to grow on a plate until you can see them, and then we can pick them and grow them up and stock them. So we keep them in a freezer indefinitely at -80 degrees, and then we can grow them up again then to test them and look for different things like if they can survive acid or bile and different things that they would have gone through in the gut. This is a plate of lactobacilli which we've grown up from one of the fecal samples, and I'm testing it for different probiotic traits just to see if it can survive the gut and if it can produce anything that would be beneficial for the infants later on.
And this is a type of bacteria that we see in the feces of very healthy infants?
Exactly, yeah.
What are you hoping to learn from this bacteria, Claire?
Well, what we're looking for is really the best kind of probiotic trait. So the better that they can survive this acid or bile, then if we ever try to feed it to an infant again, then it should be able to survive the gastric transit.
Studying the bacteria that thrive in a healthy baby can help scientists learn more about infant health in general. But of course, the potential for this research is huge.
We know that reduced diversity in the microbiota is associated with incidence of allergy and other lifestyle diseases later in life. So fundamental research to understand what bacteria and what microbes, what are the causative factors of such later lifestyle disorders is vitally important for the future health of the population.
Anything that helps us understand how babies grow and develop is hugely beneficial. But it doesn't stop there. Ireland produces around 15% of the world's infant formula milk, and so the findings from INFANTMET could help companies develop new types of food for babies all around the world.